In this equation, we need to solve for alpha. Alpha is a Greek letter commonly used as a symbol for quantities in physics equations. In such equations, multiplication signs are often omitted for simplicity, but can be included for clarity. For example, in this equation, the multiplication sign separates alpha and delta t, as delta t represents a single quantity. Greek delta is associated with t, forming one complete term, so there is no multiplication between delta and t. Delta in physics indicates change, so delta t refers to a change in time. Since the variable we want to solve for, alpha, is inside parentheses, we can distribute the coefficient in front of the parentheses, denoted as I0, to expand the parenthesis. Inside the parentheses, there are two terms, number 1 and alpha times delta t. Addition and subtraction separate terms, while multiplication combines them, so alpha times delta t is treated as one term. It's important to note that alpha times delta t is only multiplied by I0 once. It's not the case that alpha and delta t are each multiplied by I0 separately, because a single term is multiplied only once. Next, on the right-hand side of the equation, there is an extra term, I0. To eliminate it, we subtract I0 from both sides of the equation. This subtraction simplifies the right-hand side to 0, which does not need to be explicitly written. At this point, alpha has delta t and I0 as its coefficients. We use the inverse operation of multiplication, which is division, to isolate alpha. By dividing both sides of the equation by the entire coefficient, delta t times I0, the right-hand side simplifies to 1, as the coefficient divided by itself equals 1. The coefficient of 1 does not need to be explicitly written. Finally, the equation can be rearranged so that alpha is on the left-hand side, completing the solution.